Let's try again, physics. The best laid plans of mice and men often go awry. So, what I'm going to do is going to be my, like, mantra for the year, which is adapt, right? I'm adapting. I'm trying to create a best case scenario, and I forget that questions just come up, and I'm glad they did, right? Today's F day. Class today was good, right? We took lab data. We talked about the lab data. We had an understanding of it. We started to do some math analyzing the data, and I realized very quickly that I was not being clear and that I needed to do more explaining. So I'm going to do that, and as such, the quiz that was scheduled for today and then got moved is hereby just canceled. And the reason I'm canceling it is because the purpose of the quiz would have been to gauge your understanding of this graphing process and the math process. So your ability to use these two equations up here, right? If I zoom in, your ability to use velocity as change in displacement over change in time, acceleration as change in velocity over change in time, right? Can you use those to calculate either based on having a graph or having a data set? Now, we took a data set, and I did not do the best job of explaining how to use the data set, so I rewound. I took my time. I tried to explain the data set. I tried to go around to people to understand, so to make sure that they understood, and hopefully that works out. All right. Now, that does not mean that I am abandoning this graph here, nor does it mean that I'm abandoning the other assignment, which was, hang on, I'll find it, which was a Google Drive document that looked like this. Not abandoning this either. Okay? I do believe that we will be able to go over this information. I plan on doing that on A-Day. What I asked of y'all for tonight, right, was to take some of the lab data, and again, I'm just going to bring up the lab data for myself. So, so the examples that I did, and I'm doing this to benefit, maybe like you started to do something and you got it in class and now you're home and you're like, oh god, I have no idea what this meant. So I'm gonna, same process I did in class, gonna do it right here. So we have grass. The procedure, what we did was we went outside, we had some soccer balls, we kicked them, and at specific distance markers, people timed how long did it take from the time that the ball was kicked to the time that it got right in front of them. And we established that there were definitely sources of error, which we can identify more clearly than simply saying human error. We could identify that perhaps the ball didn't travel in a straight line. Perhaps there were external factors. Maybe there was more wind than we thought. Maybe the terrain itself was not flat. Perhaps we did not hit the timer at an appropriate time. We didn't start timing correctly, or we ended our time a little early or a little late. There are many sources of potential error that are more elegantly described than human error. I'm not a fan of that term. I like to be specific. Again, I will try to be more specific and elaborate in my explanations. So for the grass, writing in the wrong place. We had people posted at 0 meters. Well, we didn't really have people posted there, but 3 meters, 6 meters, 9 meters, and 12 meters. And let me just ensure that you can see. You cannot see all of those numbers. Now we can. Okay, very good. And on the grass, 0 meters, it was at 0 meters at 0 seconds. At 3 meters at 0.3 seconds. It took 0.97 seconds to get to here. It took 1.26 seconds to get to here. And then it took 2.6 seconds to get to here. Now each group, there was a group that kicked the ball on grass, kicked the ball on the turf up in the batting cages, kicked the ball in dirt and the infield. Right. Each group took 3 trials, and each group member averaged out their 3 numbers to get a single time. It's another source of error. Potential error is that it wasn't the same force, it wasn't the same kick each time, so there might have been some pretty strict variance in that. I'm hoping that they will balance them out as a result of the average. If it does not, well, it's another lesson, right? How to collect data appropriately. Now, the 3 things that I wanted each group, each person, to accomplish was, step 1 was find velocities. So velocity is change in distance over change in time. So I can find a velocity between these 2 points. I can find a velocity between these 2, between these 2, and between these 2, which means I can find 4 different velocities. So v1 is 3 meters. Now delta, something to keep in mind about delta. Delta is the change in. It's always final minus initial. So 3 meters minus 0 over 0.3 seconds minus 0. That's easy. v2 was 6 meters minus 3 meters over 0.97 seconds minus 0.3 seconds. v3, 9 meters minus 6 meters over 1.26 seconds minus 0.97 seconds. Finally, v4, 12 meters minus 9 meters over 2.6 seconds minus 1.26 seconds. Right, and each of these gives you an answer. Each time that you do this, you will get a different answer. So that was step 1, find velocity. Step 2, find acceleration. So I can find an acceleration between these 2 points. I can find, or these 2 velocities. Do one between these 2 velocities. Do one between these 2 velocities. I think I need to scroll a little bit here. So I will simply do this. Now, I know that my acceleration formula is a change in velocity over a change in time. So I would need to do this, I would do v2 minus v1 over the time is going to really be t2 minus t1, where I would label this, right, if I'm labeling things, I would call this is time 1, this is time 2, this is time 3, this is time 4. Right. Now I'm not doing the numbers here, but this is the process. If I was doing, so that would be acceleration 1. Acceleration 2 would be v3 minus v2 divided by t3 minus t2. Similarly, acceleration 3 will be v4 minus v3 over t4 minus t3. All right. Finally, step 3. Take the average of acceleration. And this is fairly straightforward. This is as straightforward as it seems. a1 plus a2 plus a3 divided by 3. Now the trick is you're going to do this, you're going to do each of these, really, for 3 sets of data. You're going to do it once for the grass, so you're going to want to do all of those calculations. You'll do it once for the dirt in the infield, and you'll do it once, a 3rd time, for the turf that is inside the batting cages. Right? And each time you should find a slightly different acceleration. Now, make sure you write down all these numbers, show all your work, right? These calculations are the ones that I would like in, take a picture of your calculations, upload it to the assignment. The assignment should already be in my CBA. But I'm going to check that right now. And I'm going to see if it's really in my CBA. I'm literally going to my CBA right now to check this. It is not, which means that I am adding it right now. So, this is lab data analysis. Describe it as calculating velocity, acceleration, and average acceleration. Lab data analysis, which is happening on F day, which is the 28th and the 29th. And I've decided I'm going to do something at the in the description of each assignment. Now I'm gonna pull this over to my screen so you can see it in a moment. All right. So what I'm doing is I am making a line at the end of each assignment now that will be in bold, so it'll be very obvious. And when you look at your assignments and you see one from me, you will see something like this. It might say all students should submit this online. See the video that you're watching and the attached data, which I will attach shortly. It might say only fully remote students should submit this online. Hybrid students will see this in class. It might say only hybrid students should submit this online. Fully remote students watch, something else. But keep track. That bold line will tell you exactly what to do with that assignment. All right? That assignment will go up shortly, as will all of the data points, not only the 5 data points for graphs here. All right? Now we're going to do more with this data. We're going to graph it. That video will go up shortly. It'll be another video because I've droned on for too long here. I can see my timer. If you have questions, even after this, or you want to check one or two of your calculations just to make sure that you're on the right track, honestly, you can check with your classmates first, but feel free to check with me as well. All right? Take care. I'll see you soon. Well, you'll see me soon in the next video. Be wearing the same thing. Peace out, kids.